welcome again. This presentation, Invisible Walls Isolating Your Python, by Jeremiah Page. This presentation is about stop building projects that only works on my machine. Every developer has ever said this at least once, but this presentation would teach you how to isolate your Python application by executing in an isolated, reproducible environment that extends beyond the code that you write. About the speaker, Jeremiah is a long-time Python developer of almost a decade of experience. For most of that time, he has used the language to drive system programs in and on top of C. Python is a diverse and quickly growing community, and he loves to contribute to it, even as he tries to keep up. He currently helps Active State deliver secure pre-built Python projects to enterprise customer and individuals developers. Thank you, Jeremiah. The stage is all yours.
Okay, thank you for that introduction, and thank you everyone for coming out to my talk, Invisible Walls. Before I tell you how to isolate your Python, I do want to give a quick plug to my latest app I made. I think it's going to be a smash hit in 2022. Some of you out there might know that MacBooks coming out this year look a little different than they have before. In fact, if you get one in 2022, it has a notch at the top. Like iPhones and like some Android devices, they've stretched the screen so much that there's a little hole where the camera goes. Some of you might even be watching from one of these today. I am streaming to you today from a MacBook, but if you were here in the room with me and took one look over my shoulder at my boring rectangular screen, you would know immediately that I was not on the latest hardware. But I like keeping up with new things. So how do I get this new MacBook look without all the cost? Well, I write a Python application, a really quick one. So any of you that want a notch in your MacBook, you can take this file, run it with Python, and you can have some dead pixels at the top of your screen. So that's cool. I wrote this killer app, and it worked on my machine. All it's left to do is get it out to the masses craving notches in their screens. I know quite a few people who run code on MacBooks. I've got a couple of friends already lined up out the door, ready to get this application. So I hand them the file. It's only about 10 lines of Python long. I say it's super easy to run. You just have to run Python a notch above. So friend one gets the program. They run Python a notch above. And sadness, we have a stack error, stack trace. Type error. Super wants some arguments, but we didn't give it any. What's this all about? Some of you might not know why Super is demanding I give it arguments, but a couple of you out there might be having some flashbacks just a couple of years ago. Super requesting arguments is a telltale sign that you're running Python 2. This is disappointing, I tell my friend. This is 2022. We're making a modern app. We're not going to run it with Python 2.7. So we need to get a new Python. We're going to get you, drag you kicking and screaming into the future. However, don't go and delete that old Python. Don't move it, don't change it, don't try and just pretend it's not there. Because it was put on your system for a reason. It's doing some jobs. There's probably something running that's expecting Python to be there and to be version 2.7. So first thing we're going to do is get you a new interpreter, but we're going to keep it separate. We're just going to forget that you have a Python on your system at all. A Python 2 anyways. So tell them go out and get the latest Python. We're going to go straight to the future. But when you go to re-execute a notch above program, I'm going to need you to be a bit more specific about the Python you're running. Because you already have a Python and it's already decided that it's version 2.7, you're going to have to say Python 3. Okay, that's not too hard. They go and do this, and they run a notch above, and we have this new stack trace. Okay, import errors, mappings doesn't come from collections. This did not happen on my machine. Some of you might know what's going on here if you like to follow what's new in Python and who doesn't. If you follow what's new in Python 3.10, you might have remembered that the mappings object has moved modules in the core. So there's a breaking change where it can no longer be imported from collections in 3.10, but it could in 3.9. Okay, and the problem is this is actually in my dependencies code. It's not even my code. I can't really fix it for my friend. So I say, okay, go back. We're going to get you a new-ish Python. Pick any supported version of Python you want, except 3.10. In fact, I tell them, just go ahead and pick 3.9. It's the one that worked on my system. So they go and get it. But now I tell them, when you go to run notch above again, don't run Python. That's taken by 2.7. Don't run Python 3. That's taken by 3.10. You're going to have to be super duper explicit about your Python. Say Python 3.9, please run my program. When they do, they get a notch. And they're happy with this. I'm happy with this. My program's running on 2 machines now. It's twice as many as before. So now we have some information to take to the next user. This is how you run the program. First, you have to go and get Python 3.9. That's the one we know it works with. Then you're going to have to install a dependency. There's only one dependency for this program. That's it. But you're going to have to be super duper explicit about your pip version. Because you already have a Python and it's not the one we want to use, you probably already have a pip. And it's probably linked to the Python. So if you just pip installed this dependency, it would go somewhere unfindable by the 3.9 runtime. So we have to be explicit about both these. If you do that, you'll be happy. And the users generally are. They do this and it works. Have lots of happy users. In the meantime, friend 1 has gotten into some side projects. They've decided to try SaltStack, which maybe you know, maybe you don't. It's a lot like Puppet or Ansible. It's a configuration management tool. So it's capable of keeping a single computer or fleet of machines in sync with a sort of profile. It's written entirely in Python, so they thought that was pretty cool and they give it a try. When they run it, nothing too bad happens. It passes all its tests, but it's throwing out some like type mismatch messages. Anyways, my friend forgot to turn his notch on, so I'm gonna go do that right away. It's a favorite part of his new computer, old computer rather. But there's a problem. He has a runtime error. Wrong version of PyObj-C. This was working yesterday. Why are we getting a runtime error today? Well, it turns out notch above has one dependency, but that dependency has a dependency. So my grand dependency is PyObj-C, which is a Python module that's a wrapper around native Apple APIs. Now, Salt also has a dependency on PyObj-C, only it wants it to be installed in a different version than what a notch above wants installed. They're both sharing the resource of this library directory where things go when you pip install them. And so when both of them asked for the same library at different versions, really neither of them got what they wanted. In this case, SaltStack kind of got what it wanted in that it was able to actually run and push past its errors, but a notch above got nothing. It got to give me a runtime error. So how do we fix this? We have to isolate our packages. So both programs want to use Python 3.9. We can give it to them, but they have to share their library space. We don't want that. We want them each to pretend like they're the only Python thing installed on the system. The most usual way Python isolates its packages is through a virtual environment, which I hope all of you out there have at least heard of a virtual environment. But if you haven't, it kind of works something like this. It takes a certain Python installed on your system and makes a copy local to your project you're working on. And then once you have that local copy, anything that Python does is also local to your project. So when you install a project, the libraries that come with it are installed local to your project. The binaries that might come, or not binaries, maybe binaries, executable scripts that come with it are also installed locally. And by being installed relative to your project, it makes them not visible to any other virtual environment or the Python that originally created the virtual environment. Now in Python, there's a lot of different ways to make virtual environments. They all have kind of different opinions on what they do and how they do it. And this is just a few of the most popular projects that create virtual environments. It can be a bit overwhelming, but we're going to just look at VM because of all the solutions. It's the only one that comes with the native Python. So it's a core module. You can import it. You can also run it from the command line. So we're going to run it and give our new virtual environment a memorable name. And once we've created it, we have that local copy, but it's not doing anything yet. So we have to activate it. Once we activate it, all the magic happens. We no longer are sharing a library space with other applications on the system. So I tell my friend, go and put a notch above in a virtual environment. And while you're at it, put all your other Python programs in a virtual environment as well. SaltStack wasn't too happy with what it had, and you don't want your next newest Python project to mess it up as well. Oops. So my friend does this. They put a notch above in a virtual environment, and it's working again. You'll notice maybe that we've gone back to the original example on my machine where we just have to run Python a notch above. And that's because we're in an activated environment, so there's no other Python. There's just the one that we need. You know we're in an activated Python because it changes our command prompt, which is a nice little feature to let you know what's going on. You can see here we switched the virtual environment because our command prompt is showing us a different name, but we haven't moved anywhere in the file system. And now when we call our salt tests, they work without error messages and without disrupting our notch, which is still running above. Great. So we've changed the instructions to new users a little bit. It's grown a bit in instruction steps. You now have to get the latest Python. Well, not the latest, but a newish Python. You have to immediately create a virtual environment out of it. Then you have to activate it so it does something. Then we again pip install our dependency and run our program. Now, pip and Python both no longer have to be hyper-specific here. Once we've activated, the pip that we use is the one that we're supposed to use for this project, and the Python is the one that is attached to this project. The steps have grown quite a bit, but it's mostly setup. There's still just 2 steps to actually run the process, so it's not too bad. This works, and more users get to use a notch above. No one's complaining about stack traces. It's all just working wonderfully. Meanwhile, friend 1 goes back to his Salt projects after spending some time messing around with some open source projects. And one day they turn on their tests again, and they get this huge monstrosity of a stack trace. Oof. This was working yesterday, and now import error something symbol not found of comp get type. All right, so what happened here? Are we in a virtual environment? Let's check. Yes, we're in a virtual environment. Our notch is still running, but we have a symbol not found, which is actually a C error. This is a C error wrapped in a Python error thrown out in a Python stack trace. This is basically C's way of saying name error. You try to use a variable that doesn't exist. Why doesn't it exist? It existed yesterday. Turns out this is from the SSL module, which is not Python code. It is a open source project, usually. That's not part of the Python project. It's not maintained with Python or distributed with Python. Python does come with an SSL module in the core, but that module doesn't actually contain any real business logic to do SSL. It's actually just a wrapper that, when you run it, dynamically goes out and looks for a C library that can do SSL to load it in at runtime. Usually your SSL module that does the business logic is provided by your operating system. And so if you were to change it, say by installing from source a new OpenSSL module on top of the old one, even though it's at the same version, you might get an error like this. Because it's outside the Python ecosystem, it's not a Python module, it's not Python C code, it is not protected by the virtual environment. So how do we isolate this? Well, we want to go beyond Python code, and we want to move to isolate our entire execution stack. So everything above the kernel whatever language is written in, we want it all isolated. So that would be our user space, everything above the kernel. One way to do this would be with runtime isolation. Now, some of the tools that we actually saw on the virtual environment page were runtime isolation tools. So they are tools that work beyond just the C language. So state tool and conda are both capable of making this all language virtual environment. It works with your Python code, your C Python code, your C libraries, and any other language that you might need. That's kind of cool. There is another, perhaps more well-known user space isolation tool, and that's Docker, or containers in general. Containers take a bit of a different approach. So far, we've been very targeted with our isolation. We find a dependency that we want to have exclusive control over, and we isolate it. Docker goes the other way and kind of takes a shotgun approach and just says everything's going to be isolated. Truly all your user space. Every file, whether it's a program file or a configuration file or a device driver, every user ID, every PID, it's all isolated. Which is great if you're running an application that doesn't care what system it's running on, just wants to run some code. But my friend is running two programs that very much care about the system they're running on. They want their notch above program to actually display pixels to the screen, or rather not display them to the screen. They want a salt stack to make changes to the configuration. That's the whole point of it, is to save those changes. So if we were to put either of them in Docker, for one, it won't be able to talk to underlying systems very well. And for another, Docker on macOS is actually just a virtual Linux process, so it would be hard, if not impossible, to talk to those native Apple APIs through it. So we're going to go with the first approach instead. My friend makes some state environments, 3 of them here, and moves on. So these first 2 are just examples showing that we can use the exact same version of Python, but at runtime dynamically link against very different versions of OpenSSL. And both those OpenSSLs are isolated. They're different than the one that was installed by Homebrew, and all of those are different still from the version that's installed by macOS. And they can all work independently of each other. And just for a little extra protection, they also put a notch above in a state environment. You can see that if we run the program from within the state environment instead of a virtual environment, we can still affect change on the underlying system. So we change our steps for new users to be able to run a notch above. First, you activate a state environment, then you install your one Python dependency, and then you run Python. No need to be hyper-specific after you activate, just like with a virtual environment. Great. So we just took a whirlwind tour of many different ways you can isolate your Python program. But you're going to have to leave here, and you're going to have to actually choose which ones to use and how to integrate them with your application. You might have thought, as we were moving down the stack, that each layer we descended into covered more isolation and so made all the previous layers irrelevant. And that is often the case, but that is not always the case. You can actually combine these different layers, 2 or 3 or sometimes even more layers together, if it's what you need. If you're running a container, sometimes we run multiple processes in that container. If they're both Python, then they should probably have an isolation inside the isolation of the container, so that you don't have to manage any conflicts between the requirements. Even if you're only running one process in a container, are you really sure you're never going to want to log into that container and run some other Python code? Yum would be an example that you might have just messed up your ability to run Yum. But don't overdo it, Just because you have these layers of isolation doesn't mean you should go straight for the biggest one or the one that's most popular. Adding each of these layers, either a single one or multiple of them, adds a cost to your program. It adds a cognitive cost as you go out and learn that tool and then try and integrate with your application. Most all these solutions are going to add disk size to your application, probably process overhead as well. And it's going to add a lot of complexity, and you don't need to add complexity just for complexity's sake. So with your application, go and figure out what dependencies on the system it thinks it has exclusive control over, and definitely isolate those. So that would be your direct dependencies, of course, your transitive dependencies it thinks it has control over. It's transitive dependencies that maybe aren't Python code. Your C that you're calling, that's not C Python. It's going to be hard to do, but that's probably where you want to start to draw your lines. If you rate a wonderful Python script that only depends on core modules, can run any version of the last 7 of Python, you might not need any of these layers. Just hand it out. If anyone has Python, they can probably run it. Now I know I just told you to moderate your isolation, but there are a couple reasons to add layers of isolation that aren't just about keeping control over your dependencies. I would note some of these as social reasons, perhaps, to add a layer of isolation. And that is, you want to consider not just what the minimum layer of isolation is for your application on one machine, but on every machine where it might be deployed. So on test, maybe you're sharing that resource with other applications, but in production, you're not. Maybe you have different developers running on different machines, and so some of them absolutely require a virtual environment, or it's going to mess up their other projects. But maybe one of your other coworkers doesn't run any other Python. If you're all running in different isolation modes, it can be really hard to collaborate with your coworkers. It can be hair-pulling to go to production and try and debug what's going wrong. If every path looks completely different, has different permissions on the files, if your load order is completely different than what it is on your local machine. So consider if it makes sense to maybe find the largest layer of isolation you need on any system you're deploying to and use that everywhere. That's not always what you need, but consider it as another option. Thank you all for coming out. I have this question slide, but I think I have to go somewhere else for that.
Exactly. Thank you very much, Jeremiah. That was a wonderful presentation. Later, you'll see the chat, all the conversations that created the examples that you were showing to us. Want to thank you again for taking the time of showing us how to isolate our Python so we don't run into it runs on my machine ever again, or try to reduce the time it ever happens. Our next presentation will be literature text translation and audio synthesis with AI services with Vivek J. Ray Rahat. I hope I'm pronouncing it correctly. If not, I'm so sorry. We will have a 15 minutes break as usual. So we will hope to see you all back here at 3:50 Pacific time. And also, do not forget to check the Microsoft Virtual booth right here in the VenueLess application. Again, Jeremiah, thank you again for being with us today.